This is problem number 2 on sample test problems for test number 1. Simplify each of the following expressions as much as possible. Write your answer without using negative exponents. Part A, 2x squared minus 3 times x plus 9. So here we FOIL everything together. So we'll first multiply the 2x squared times everybody. And then we'll multiply the negative 3 times everybody. It's our job to combine like terms, but in this case there are no like terms, so we're done. Part B, 3x to the negative 4, all raised to the negative 2. First thing, that negative 2 comes in and hits both terms, so it's really 3 to the negative 2 times x to the negative 4 to the negative 2. 3 to the negative 2 really means 1 over 3 to the positive 2. That's how we deal with negative exponents. And then when you see exponents that look like this, negative 4 and then raised to the negative 2, we know we're supposed to multiply them. So there's the x, and then we multiply negative 4 times negative 2 and get 8. And then finally, that's a 9 on the bottom, and we'll go ahead and put the x to the 8th on top. Part C, 4x to the 1/3 to the 3/2. This is the same idea as part B, so we're going to bring that power in first. 3/2 is going to come in and hit both of these guys. So this equals 4 to the 3/2 times x to the 1/3 to the 3/2. And now we need to deal with that 3/2 power on the 4. What does it really mean? Well, fraction powers mean radicals of some kind. The 3 either goes in here or out here. I always choose to put it on the outside. I think it makes the calculations easier. And then the 2 is the index, so that's a square root of 4, whole thing cubed. And just like in part B, when you see powers that look like this right next to each other, you multiply them. So if we multiply those powers, we get x to the 1/2. Almost done. Now we'll deal with this part over here. Square root of 4 is 2, so that's really 2, still cubed, x to the 1/2. And then finally, that's equal to 8, x to the 1/2, or if you prefer, 8 square root of x. Part D, 12x to the 3/4 divided by 3x to the 1/2. Okay, so first we can deal with the 12 and the 3. So we know that they cancel and we reduce to 4. And I guess I'll put a 1 down there. And then how do we deal with powers when they look like this? So in this case, we have x to a power divide by x to a power. And then we're supposed to subtract those powers. So it should be x to the 3/4 subtract 1/2. I'll put it in parentheses. We don't really need it, but just showing you that that whole thing is the power. So there's a 4, there's an x. If you make an LCD, you'll see that you get x to the 1/4. No need to put the divided by 1. If you prefer, that's a 4, and then 1/4 as a power means 4th root. Part E, 2x over x squared minus 1 minus 2x plus 1 times x squared plus x minus 2. So in this case, we need to find the LCD. But in order to find the LCD, you want to factor the denominators first. So x squared minus 1 is a difference of squares. Minus, I'm going to leave a little space right there, minus. Let's see, so this is going to be x plus 2 times x minus 1. Okay, and then we need to find LCD. And so the LCD here is, let's see, I'm going to copy the things as I see them. So I see the x minus 1, and I see the x plus 1, and I see the x plus 2. So I'm going to write those 3 things. And then the last thing I see is this x minus 1, but I've already got it, so I don't need to write it again. So this is our complete LCD. And so then I'm going to fill in the stuff that's missing. So in this denominator here, I have x minus 1, x plus 1. That's these two. But what I don't have is the x plus 2. So what I need to put in right there is an x plus 2. But I can't go around multiplying the bottom of a fraction by x plus 2 without paying for it immediately by multiplying the top by x plus 2. Same idea for the other fraction. I have x plus 2. I have x minus 1. What I need is an x plus 1. So we're going to put that right in there. And then we got to pay for it right away. On top, x plus 1. And just to be clear, that whole thing is getting multiplied by the x plus 1. I'll put the parentheses around the 2x, even though we don't need them. And now that we have the same denominator, we're going to multiply everything together up on top. So distribute, we get 2x squared plus 4x divided by the whole denominator minus, and then we'll FOIL up here, 2x squared plus 3x plus 1 over the whole denominator. And now the idea is that because they have the same denominator, we can merge them together. So the whole denominator is down there, and I just have one fraction, 2x squared plus 4x minus 2x squared plus 3x plus 1. And then all we have to do is combine like terms. I'm warning, it's really easy to make the mistake that I've made here. This 2x squared plus 4x is one thing, but parentheses. Although that isn't the one that matters, it's this one. That minus sign needs to distribute. Okay, so combining terms. I have 2x squared and minus 2x squared. They cancel. Then we have 4x, subtract 3x. Just gives me a single x. And then it looks like a plus 1, but it's really a minus 1. And then now finally I'll copy that whole denominator that's been up there the whole time. X minus 1, x plus 1, x plus 2. And normally at this point we'd be done, but in this case you can just cancel. This x minus 1 is the same as the x minus 1 on the bottom. So we'll make it a 1 over, which means our final answer is 1 over x plus 1, x plus 2. Part F, 1 over x plus 1 over y, all divided by 1 over xy. So this is called a compound fraction, or I think a complex fraction, and our job is to fix it up. So I think what we want to do is multiply both top and bottom by the LCD of all the fractions you see. And the LCD of all the fractions in this case is x times y. So I'm going to multiply up here times xy, and I'm going to multiply down here times xy. And just to really make it clear where things are, I'm going to put each of these over 1. So multiplying top and bottom by xy. Nice things happen on the bottom right away, because on the bottom, this xy cancels with this xy, and we're just left with a 1. On the top, nice things will happen as well, but it takes an extra step. First, we're going to distribute. Xy is going to come in and hit both terms. So I've got 1 over x times the xy that came in, plus 1 over y times the xy that came in, equals, and now good things happen again. X cancels here, y cancels here. All we're left with is the first term is a y, second term is a plus x. No need to write the divided by 1.